Okay, in this tutorial, I'm going to be introducing you to the use of a statistical test known as a Spearman Rank Test. So first of all, this is a statistical or mathematical test that will allow you to prove, disprove, mathematically that is, whether there is a relationship between two variables. Okay, in this case, in this example, our first variable is the distance along a beach, and our second variable, it is the average size of pebbles taken at each of the locations being studied. What's important is that you have pairs of data. So here we have at our first location, the average pebble size, let's just, for example, say from 10 pebbles that were selected, is 76 millimeters. And they belong together, so they are what we call a pair of data. And the second location, we had the average size of pebbles was 63, and they are a pair of data. Okay, when we talk about the n, or the n size, we are talking about the number of sites or the number of pairs of data that you have. In this case, we have 10 pairs of data. So our n is 10. Okay, so we're going to explore this idea of using a Spearman rank in a second. Why would we want to do that? But if we were geographers, we would probably first of all be interested in actually establishing what kind of pattern do we have. So let's just assume we are moving along a beach from one end, let's just say in this, for argument's sake, the eastern side of a beach, and we're moving to the other side, which is the western side of the beach. And we have stopped at equal intervals, let's just say every 50 meters, and taken a sample of 10 pebbles. So that would actually be what we call a systematic sampling strategy. We've equally spaced intervals along our beach. Right, we now want to see what's the general pattern, what's happening to our average size. So what I would probably do as a geographer is the first thing is I would just come up with a very simple graph. I'm just going to use this insert chart. And now in this case, because I'm looking for a pattern along a distance, I can use a line graph or a bar graph actually, because a line graph is used to show a change over either time or over distances. And because each of these sites is further along the beach than the previous one, so these are all connected to the previous one, as in each one is after the other one, line is acceptable. Actually, in this example, a bar graph would also be acceptable. Okay, so what am I seeing first of all? Well, my simple piece of analysis is suggesting to me that I have this pattern where the average size seems to be getting smaller, but I've got an anomaly at site 6 that doesn't fit my overall trend, which is of rock sizes getting smaller as I move from my east to my western side. And I would therefore want to hopefully have taken a photograph here, and I'd be looking at what's causing that. So that's the kind of the geography in me and a little bit of analysis if these were my results. Okay, what I then might want to do is begin some analysis at seeing, is there an actual relationship? Now the line graph has suggested one, but I have a tool at my disposal called a scatter graph, which is actually a graph designed for detecting relationships. Okay, so if I scatter my data, I can see my scatter suggesting this. I am going to also just add to this a trend line, which I should find somewhere in here. I'm just trying to remember where that is. It's one of the options in the chart editor, which you just have to find. Okay, I've now found it. It's in the series tab of the customize and the chart editor, and you go down and you hit your trend line. Just going to close my chart editor by clicking up here. And what I can now see, if I just reduce the size so you can all see this, is a scatter graph with a trend line going down the way. So what my scatter suggests is a negative relationship. Okay, so what that means is as I move further along my beach, so as my site numbers increase, my average rock size decreases. So I have a negative relationship. I can see that most of my sites are quite near the line of best fit, So I would suggest I have a fairly strong negative relationship between distance along the beach and rock size. Right. Unfortunately, the scatter graph doesn't actually statistically prove that. It just visually suggests that there is a relationship here. So what I now need to do is go to my final step, which is conduct a statistical test. And I'm going to use one of the weaker tests, actually. Mathematicians often prefer other ones, which you will be taught during this course, the Spearman rank. Okay, so what the Spearman rank requires me to do, first of all, is it requires me to set up what's called a null hypothesis. Okay, now a null hypothesis is basically a negative hypothesis. You should all be familiar with what a hypothesis is. It's what you think will happen. The null hypothesis is the opposite of that. So let's just explore it a little bit more. Let's just assume that my hypothesis was that as I move further along the beach, as I increase distance along the beach, the rock size will decrease. So that could be my hypothesis. So I think that there is a relationship between the distance along the beach and the average pebble size in millimeters. My null hypothesis would therefore be I think there is no relationship between the distance along the beach, which is column A, and the average pebble size, which is column B. So that's the null. Now, when I do the Spearman rank, I am looking to disprove that null. And I'll talk more about how I can disprove the null. But that's actually what you have to do. That's just the mathematics behind it. You do the test and you disprove the null hypothesis. And by disproving it, if I disprove it, I will end up proving the actual hypothesis, or actually what mathematicians call the alternate hypothesis. More on that later. Let's do the test. Now, luckily, we don't need to do the maths anymore. We're geographers, we're not mathematicians, and the internet will do it for us. So what I'm going to do is I'm going to select my first variable. Now, this is what I call my x variable. So it's my sites 1 to 10. I'm just going to copy them using the Control-C button. That's assuming you're using Google Chrome. I'm going to go into my online Spearman rank calculator. Here it is. And I'm going to paste that with CTRL V. And that's now pasted 1 to 10. Now my y variable, which is known as my independent variable, it's the one that changes when this one changes. I want to go back to my spreadsheet. This time I want to select my second set of data. And I'm going to do Control C. I've copied them. And I'm going to paste them into my y values. Right, now I can see that number 1 is matched up across to 76 millimeters. I don't need the units, by the way. Number 2 to 63, and so on and so forth. Right, I'm now going to calculate the result. And I'm hoping it's doing this. There we go. So what it's now going to do is it's going to do the maths for me, and it's going to return this result here. It's negative 0.8. Okay, now, first thing you've got to understand is this result could have potentially been anything between -1. Now, that would mean a perfect negative relationship. What that means is as each of these values goes up, the value on this side would be going down. Or the other possible result I could have got was +1. If that was the case, as each of these gets higher, each one of these in turn gets higher. Now I've got negative 0.8. So what I first got is I have a negative relationship between these. What that means is as x goes up, y goes down. So the value of y gets smaller. It's not -1, but it's quite close. So I would be going a little bit further. I'd be saying I would suggest there's a strong negative relationship. So negative 0.8 suggests a strong negative relationship. Okay. Now, this negative 0.84 requires me to do one step further. I haven't yet disproved my null hypothesis, even though it's suggesting that there's a strong relationship and therefore that the further along the beach, the smaller the rock size becomes. I need to do one final step. Let's remember that negative 0.84. Okay, I need to go to what's called the table of critical values. Okay, now here's a resource that I've given you in your lesson this week, which actually explains how you do all the maths. We've skipped all of these steps by using the online calculator, but on the last page, it does show us a result, a little slide rule, and it suggests that if you're anywhere between this number and this number, or this number and this number, then you have a strong relationship. If you're somewhere between -7 and +7, then it's possibly a bit too weak. Well, we were above this, but actually let's pay more attention to this little table. This is the key table. Okay, now Rn, that's the number of pairs we had, was 10. Okay, what we therefore require is our number or our result. Now let's remember what that was. That was -0.84. Is it higher than these results? Now, one thing you've got to, which gets a little bit confusing, is let's just, for argument's sake, imagine these are all negatives. These are all positive values, but we have a negative version of this table as well. Is our negative 0.84 bigger than this, or negative this number? Yes, it is. Is it bigger than this? Yes, it is. Is it bigger than this? Yes, it is. Negative 0.8 is larger than negative 0.733. Now, what we've now done is, as soon as we get above this number here, we are able to say the following. We are able to instantly reject our null hypothesis and accept our alternate. So we would be saying, we're rejecting this idea that there is no relationship between distance along the beach and Pebbleside, and we are actually accepting that there is a relationship. And because we're above this number, we can say that we are 90% confident because our result of negative 0.84 is larger than the 0.44. However, it's even bigger than this one. Let's ignore this one. Let's go to this one. This one is, we are 95% confident that there is a relationship between distance along the beach and the average rock size. Well, hold on. It's actually bigger than this one. So let's reject this one altogether, and let's now think about this. If we can get above the 0.01 significance level, we can actually say that we are 99% confident that there is a negative relationship between the distance along a beach and the average size of a rock, and that we would say that for 10 pairs of data, or our n is 10, because it's bigger than the required value of 0.733. And you can see here that they've written how to report your results based on your result. So you're going to be asked to do something just like this. You're going to be asked to do the calculation using all the steps that I've got. I'll give you some different data in the spreadsheet. You will have to decide, is your result bigger than this? And what does your result mean? If it does get above this, then you would automatically be rejecting the null hypothesis, that there is no relationship. If it gets bigger than this, you can then skip the 90%, that you're 90% confident, you're actually 95, and if you can get bigger than this one, you're 99. But pay attention to what your result is, because it won't necessarily always be bigger than the one you want. And it might not even be big enough for here. And if it didn't get above this number, you actually have to accept the null hypothesis, which means that there is no relationship. Okay, so that is your first little steps, baby steps into using statistics to prove results. The nice thing about Spearman Rank, and we use it, and you want to just pay attention to this last bit of today's tutorial, because what Spearman Rank does is it provides you statistical evidence to support a theory that you have. Now, the theory that you have is that as you move further along the beach, that the average pebble size is going to decrease in size. And it will provide mathematical support for that theory. Okay, Spearman Rank is also gives you strong evidence. It's using maths rather than a visual observation. A scatter graph would just be a visual observation graph, whereas this gives you a mathematical outcome. It's a simple statistic to calculate. It's not a difficult one, so even the more limited mathematicians amongst you would probably find it not too difficult to complete one of these on paper if you had to. The result is reasonably easy to interpret as well, because it goes between -1 and +1. So it's telling us whether we have a positive or a negative relationship between our two factors. So that's its strengths. There are some negatives of this particular test, but I'm not going to explore them with you today. And it's something that we'll do further down the road when we start looking at other tests as well.